So welcome to this month's Devel Forum. Thanks everybody for turning up. There's definitely a few new faces again, which is really good. It's really encouraging to see. And hopefully we have a really interesting, slightly different set of topics about today than normal. So today we've actually got a presentation by some relatively new Bioconductor developers. So Joselyn, Carmina, and Emiliano are going to present about their tool and their experience with developing the tool in their team. So they're from the community of bioinformatics software developers. I hope I got that correct. From Latin America, and yeah, this is their first experience with sort of working with the Bioconductor framework and submitting to it and things. And I think it would be really interesting for those of us who've been embedded it for years to see how that experience is for people that have come from outside for the first time you're experiencing how it works. And also, hopefully, it's going to be really encouraging if there's anybody on this call who watches it later that hasn't done this before and wants to know what it's like from that kind of perspective. So I think this could be really valuable, and I'm really looking forward to the presentation. And then afterwards, I have a few sort of more free-flowing things about unit testing that's been motivated by a few discussions in the Bioconductor Slack and some of my experiences kind of building up to making sure everything passes check just before the release. But that's definitely the secondary thing. I'm really looking forward to this talk. So I don't know how you guys are going to structure it, but feel free to take it away now.
Yes, we have a presentation. I think I can share our screen. Can you see the presentation now?
Yes, that's right. That's good.
Okay. So thank you so much for inviting us. We are very happy to be here. And as Mike was saying, we are Joselyn, Carmina, and Emiliano, and we want to share with you our experience as first Bioconductor developers. And before start talking about our package regutools, we want to do a little recap about the community. That is the community of bioinformatics for software developers. By the acronym in Spanish is the CDSB. This community started 2 years ago because of the concern of increasing the number of Latin Americans in the Bioconductor community and in the art community in general. So this community was started with 3 enthusiastic ex-alumni from the Center of Genomic Sciences of the UNAM, Mexico, that become great researchers now. That was Leonardo Collado, Alejandro Reyes, and Alejandra Medina, and with the support also by 2 members of the university, that is Delfino and Eladia Salgado, who believe in them and believe in the project. And I am happy to share with you that last year I passed from being an alumni and joining the board team. And also I will be part of the instructors of the workshop of this year. Since one of our main goals as community is to encourage the path of being an our user and become a developer, the CDSB, together with the National Node of Bioinformatics and the Mexican Network of Bioinformatics, has been organized a yearly 1-week-long workshop. From across these years, we have been supported by the ARC Consortium and the Bioconductor. So not only as our sponsors, but also by joining us during the workshop. For example, in the 2018 workshop, Martin Morgan and Benilton Carvalho from Brazil joining us as part of our instructors. And me as an alumni, I was very happy to see them in the workshop because we had the opportunity to meet them for the first time in person and also to learn from them and their great experience as developers. And I have also a beautiful picture from the workshop of the last year that was about how to build and create IT tools. And I don't know if is Carmina already here in the talk, because yes.
Yeah, I'm here. But, this is part of the Emiliano's.
Yes.
Wait, I think Emiliano, I saw that he was also in the call. Are you there, Emi?
Yes, I don't
Sorry.
know if Emiliano is there.
He's not.
Emiliano, are you listening us? I am not sure if Emiliano is here.
He's written a message in the chat. Yeah.
I don't know if his microphone is not working or something.
Yes, he said it.
Oh yeah, his microphone doesn't work. That's what he said.
Okay. Now you want to talk about this part? Yeah.
Or should we wait a little, or for Emiliano, or? Emiliano, do you want us to wait for you to configure problem, or should we continue? Well, so I will say this part. Yeah, so what is regutools? So regutool is a bioconductor package that is a bridge between RegulonDB, that is a prescriptional regulatory and prescriptional database that works with E. coli organisms, and this we want to have a bridge between RegulonDB and his, because now it has like a web interface, and we want to have a bridge with Bioconductor and the other package, so it will be easier for the user to extract the information from for RegulonDB and use it in R. Next slide. Yeah. So how everything starts. So Emiliano and I are part of the undergrad program of genomic science. Alejandro and Leo were also part of this undergrad program. And here we have to be enrolled in a laboratory for 1 or 2 semesters. And we decide to be enrolled in the computational genomic lab. That is a laboratory where Regulon is created and is maintained. So, and our advisor in this internship was Jose Alquicira, who's in the middle of the picture. So we have the opportunity to choose what project we want to participate, and we decided that we want to do something related with RegulonDB. So they told us that we have to design a tool that solves the problem of the programmatic access to RegulonDB and make analysis more reproducible. So we start to design the package, and we start to code and try to see the way that will be more easy for people, that because we want people that was familiar with RegulonDB but maybe not with R to be able to use the package, and but also people that were already familiar with R and Bioconductor to use the package and have all the get the maximum of it. So after 1 year, next slide. Yeah. So after 1 year of working on this, we have the function that, well, the main functions that we thought that were necessary, and also we have an ACQS Lite database version of the original Regulon DB database. So here we thought that we were like finished, like we have all the functions and everything, but we were kind of lost of what to do next, or what was missing in the package, what if that was everything that we need. So here's where the community, Leo and Alex, come to save us. because Joselyn and Emily took one of these workshops where they learn how to build a package and all the steps and the proper way to do it. So we go from having the functions and the SQS database to actually have like a package in form with all the in this part with Jocelyn was already part of the package, and we have the functions improvement. Also, we have more documentation. We Alex help us with the. We have a really nice vignette. We also do a lot of tests. So now we have 94% of the code test, and we also integrate a workflow for the user to have an idea of what you can do with regutools. Next. Okay, so the regutool team now is, these are the people that are involved, and so the developers and mentors, and again I want to thank a lot to these two, are Leo Collado and Alejandro Reyes. The developers alumni are Emiliano, Joselyn, and myself, and also a very important part is the DB maintainer, Eladia Salgado, that we also thank a lot because she facilitated the SQLite database and helped us with all the connections with DB. Also, as she also helped us with the needs that DB has, and she's like the bridge, so she tells us how they want in the package, what they need, what the users use more. So that's the team.
So now we want to share with you some examples of the functions that regutools have. These are not all the functions, but we think are the most used. So the first and important function is connect database that allows connection between our environment and the annotation hub where we have put the full database from E. coli at this moment. And once we have connected with the database, we wanted to integrate our workflow with the Bioconductor environment. So in this part, Alejandro had a very important role because he helped us to construct a new object that we call a regutools object that is very important for the next steps because this object takes in account all the information and the metadata from the E. coli genome, and is expected in the future that the database have also more organisms. So that's why we wanted to keep all the information about the organisms that we are working on. In this case, we are using the organism E. coli, and also this object takes into account the genome version and the database version to keep this information across the workflow. Also, these functions are list datasets that allows to see all the datasets contained in the database for this specific genome. So we can see that, for example, we have a dataset with DNA objects, with genes, with networks, because this database is focused on the transcriptional regulation of E. coli. And also for each one of these data sets, we can extract and see the column names that we call attributes. So for example, for the data set with genes, we are seeing the attributes that is the ID of the genes, the name of the genes, also another the V number or another IDs, and also important information like the genomic positions of each of these elements. I think Emiliano was participating here.
Yeah, so I can take this part also. Yeah, so now that, as Jocelyn explained, we have the access to the database, and we can see all the data sets that are there and all the attributes that it has. So here now we have this function that is called getDataset, where we can build a query to extract the information that we want. So the parameters that are in this function is the RowLongDB access, that is the one that Joselyn just explained. Also the dataset that we want to extract the information, and we have the attributes that we want to have in the final object that we are going to receive. And we can filter these attributes by here the filters, where you can decide if you want to just filter by one attribute or more. In this example, we're filtering by name. We want from the dataset gene all the positions and the strand and the name of the genes that have the name RC, CRP, or LAC in the attribute name. So this is how you build a query to database, and the result is a RowLongDB result that in this case has 3 rows and 4 columns, where you have the site attributes as columns. Yeah. So another important thing is that you can store the metadata of the query that or the result that you were trying to get. This is really useful because it will help with the reproducibility of the analysis. So you can have, in this case, you can know from which organisms, which genome version was extract this information, the database version also. So so this will come useful when there's like a new version of the genome and you want to do like the same analysis, but you don't want to do it with the new version. You want to confirm that it was the same with the old version. So, yeah. Next. Yeah. So what are other things you can do with regutools? You can extract and visualize regulatory networks. For example, here we have the function getGeneRegulators, where you can put the names of the genes and it will give you the regulators. And in this part, we want to have a visualization. So what we did is that we connect. You can connect the regutools with the Cytoscape in order to have a visualization of the network like the one that we saw here. And the next one. Yeah, so we also want to integrate it with the Bioconductor ecosystem. So we want to be easy for the user to take the output of regutools and use it in different packages. So in this example, for example, we can search binding sites and retrieve them in different formats. In this example, with the function getBindingSites, we can get the binding site for RSC, and we can see here the result in the format of G ranges. But if we want to do it with a format of DNA string set, we can do it with selecting the output format, like in the right part of the string. So, and this will allow.
I have a couple of questions. I'm sorry. How did you say you integrated with Cytoscape?
We use the RCI Y3 package that already have some function to connect between R and Cytoscape.
Okay, so this is like at runtime you can communicate with Cytoscape through some interface. Okay. And what about have you guys thought at all about returning deferred data structures here? So, for example, this delayed data frame, you could, for example, you could call getBindingSites and not specify a transcription factor, and it would just return, a delay data frame of everything, and then you could then restrict by the transcription factor, and then it would do the necessary query on the fly.
You can see the full data set using the first one of the first function that was a get dataset, and you can select the dataset that contains all the transcription factors with the binding site. Actually, this function, what it's doing is that we take that dataset and implement more use or easy for the user to access to that. But you can see the full dataset also.
Yeah. Okay. Yeah. I was just it'd be interesting to see in terms of some of these database query interfaces to start using some of this infrastructure around returning deferred data structures like the delayed data frame and seeing whether we can use them in this context. I think that'd be interesting just to look into.
Okay.
This is great though as it is. It's great. Thanks.
Okay.
Yep. So I think that's for the functions.
Yes. So we want to share with you some things that we have learned across the process of build this package. From my perspective, one of the things that I was doing like an error as a beginner developer is that I was constructing or writing functions that was implying multiple output formats. Also, when I was changing or adding more parameters, sometimes I was forgetting to modifying the test or run them again. So that's a very good practice that I learned in the process. And also, we learn about how to implement some useful tools. And thanks to Leo, we used the Travis app that helped us to test the code and was a big difference across the building process. About writing long functions that was implying different outputs. One point that I learned is that it's better to separate that function, and that was how these two functions born, because we wanted to get all the genomic elements within a genomic range. So we want to use this function get DNA objects. We need to provide a G range, so we can retrieve all the genes or promoters or elements binding to these regions. But also, if we want, instead of get a list of the elements, we want to visualize them. We created a new function that all the thing that do this function is to plot the DNA objects. This function has basically the same parameters, but the output is completely different. So we have a kind of genome browser-like plot by using the integration with another package that is GBIS, and we can see all the elements containing within the region.
You're muted, Carmina.
Sorry. Thank you. Yeah, so what Emiliano learned from this experience was that this was like one of the first time that he also I was working with in a coding project in collaboration with different people. So using GitHub, Slack. So what he for what I remind that you usually use code and you just write your code like from the next lab meeting or to present something. So you actually like if your understanding is fine, right? But now that we were coding for more people and more people have to see it and understanding, it was like a really good experience for him, and also it allows him to get more familiar with GitHub and Slack. Also, when using the developer test coverage, it was really fun because it was like making a game, writing the unit test, because we spent like one day trying to have like the more line of the test code and see what we can do and oh, what is missing here, and it was really nice. So that's what Emiliano experienced. So one of the things that I learned, and I think is the most important, is that writing the code is important part, but it's not all. Like there are a lot of steps that you have to do and are as important as the code itself. So I think that's generally my take-home message. But I also like agree with the comments of Joselyn and Emiliano.
Could you expand a bit? What other things? So I kind of agree with you, but what in addition to the code is important?
Yeah, I think like of course the documentation, like a proper documentation, right? That where you explain like in a useful way, not only like oh this part do that, and that's all. That you have to do like all the input parameters, the output parameters. Also the documentation is important. The manual, like the vignette part, the test, that was like a part that actually like didn't know, like the unit test, like with this project, with this package, with the tool test coverage. Like I have before this, I have like no idea. Like I just like have my small test that I was manually like running, and if it works, I will say that everything works. So I think that's part. Yeah, and also like I think it was really useful like to see the other people perspective about the functions and how we can improve them. So I think that's.
Oh, great, thanks.
About the submitting process, there was very useful guidelines, and it was very useful for us to read the guidelines available by Bioconductor about the submitting process. And there were some things that we didn't know before of submitting our package. For example, there is a developers mail list that we didn't know about it before until we involved more about the community. How to create an SSH key, and we didn't know how to do this before until we have to make to submit our package. And we want to say that even the guidelines are very useful and very easy to understand for us as beginner developers. To have the experience and the guide from Leonardo and Alejandro that had experience before about submitting packages was very important and helped us a lot to understand all the submission process and also to understand the building reports that was retrieving during the review process. Sorry. During the feedback, we have as our assignee to review the package, Nitesh Turaga, and we want to thank a lot to Nitesh because of he have gave us really good feedback about our package, and we had to make some fixes. For example, keep just one maintainer because initially Carmina, Emiliano, and myself were maintainers, but we had to decide to keep me as one maintainer, but to communicate after with the rest of the team about the fixes that we have to make, and also to remove the RProj file, the R project file, adding the news file, and here Leonardo help us to understand how is the correct format to make this part, and also more technically adjustment like the lines length and correct indentation. And by the end, we have good comments about our R code and about the vignette. So the current status of the package is that we think it's almost done, but we are facing this warning about the time in the command check. I think we can talk probably about this warning in the second part of the forum. And we have a final point.
Sorry, Jocelyn, there's a question by Nitesh on the chat. He's
Oh,
asking, his question is, how much did having a continuous integration system for R, check, etc., like Travis, help improve your package before getting to the Bioconductor build system?
Because when we push a new commit before of making a version bump to run the full Bioconductor check, we can make a little commit like just in our little GitHub and the current version. And by using Travis, we can see or confirm that at least all the tests are running, all the R code is running, and even though we cannot see the different operating systems is working in our code, we at least can see that the package is running well or is building well. I don't know if you want to add some, Leonardo.
No, that's great. I think I just wanted to know how much it helped before getting into the build system. But and there's also these GitHub actions now. If you're having issues on Travis running them on different operating systems, like you can use GitHub actions to run your R command check and build on Windows, Mac, and Linux for any future packages, like if you wanted to do that. Yeah. Not
but regarding this, the hint regarding GitHub actions, it's a bit tricky to get the devil build working. So for now, I think I would stick to Travis, because the devil builds rely a bit on what the guys from RStudio can provide regarding binaries and stuff, and this might not be a good time to switch. I mean, Mike probably has a lot of input on that, what changed in building binaries and stuff, especially on Mac. But I would, for now, suggest not to try to reproduce
I'll intervene a little bit too.
builds. Yeah.
Yeah. I mean, I'm also learning how to do GitHub actions myself. But like, I think to answer a little bit Nitesh's question, I think it was helpful to have Travis before to help teach Jocelyn, Carmina, and Emiliano what the R command check output was, like see what were the things we needed to fix even before submitting to Bioconductor, and then what Jocelyn said about like testing small changes and seeing if they worked. But yeah, before the guild system was mainly about like, are we ready to submit to Bioconductor? Yes or no? Because we know that Bioconductor runs the R command check and all of that. So
That's
at
great.
least getting everything ready in one system before submitting was useful.
That's really cool. Thank you for answering. And it was a really well-written package. I'll say that again.
Carmina, do you want to say the final thoughts?
Yep, sorry. Yeah, so the final thoughts that we have is that the development process was very rewarding as a collaborative and learning experience. I think Emiliano, Joselyn, and I learned a lot of Leo and Alejandro, and about everybody. Like they were like really nice, helping us with everything, and also like explaining us all the parts. I think that was really important. It's not only that oh, there is this problem, I'm going to fix them. Like they will help us and explain us, oh, this problem was because of this, or you can try to do the put, like you do the change and do the push. It was I think that was really nice, and it will help us a lot, not only in our bioconductor developer career, but also like in our scientific careers in general. And yeah, we hope that regutools will be really useful tool for projects related with microbiological studies, and a lot of people can use it and take more from Revol on DB. And thank you everybody for being here in the forum, and again thank you to Leo and Alejandro for all the help with the project. Well, Joselyn and Emiliano for my part.
Yeah. Okay. That's all from our part.
Thank you very much. That was a really awesome talk. It was really great. Are there any questions from the, let's say, floor, the audience?
So while people think about questions, I'll just add that from my side, teaching, I'm actually getting a lot more into the Dockers by Nitesh, because something that I really struggled was how to teach testing on RDVL right now and all of that. So I think if I were to do this again, I would teach how to develop the package on a Docker, not on the regular machines, because yeah, it'll make it's just a lot easier. I've been dealing a lot with like pain from the Mac configuration and things like that. So just getting stuff in the same environment as Bioconductor, I think that will be helpful. But it also took quite a bit of time to do this, and so maybe now that we all live in a Zoom era, maybe like recording some of the sessions would have been helpful for some of the meetings we had for like scaling, right? Because Alejandro and I devoted a lot of time to this project, but I don't think we could do this for like more projects really, right? So.
Yeah, I guess one thing I would say against using Docker, which I really like, I think they're great a lot of the time, is that you set them up once and you spend quite a lot of time doing it, and then you forget all of those. Like maybe if the Docker file helps you get it perfect. Maybe my mistake is I use a virtual machine that I set up 3 years ago that works fine. But if a user runs into a problem, I can't remember what I did to get it working fine, right? And maybe actually the Docker file is the right solution to this, where you actually have a set of scripts. As long as you do it in a way that you keep a record of all the changes you made and the things that were set up. But I guess if you just download the pre-built versions and run straight from that, it doesn't necessarily emulate exactly how a user is going to have their system set up. So sometimes it's quite helpful to go through the pain getting it to work at least once yourself so you can answer those questions. But the same is true with, you only have one machine normally, right? You're working on a Mac or a Linux machine or whatever, and if somebody has the opposite, it's really hard to give advice until you find someone else or to help them with that. And that's not easy. And I guess all these kind of building approaches, like using the GitHub Action, sounds great because you can use all 3 different major operating systems, which I don't think you can do on Travis. Correct me if I'm wrong there. So that's one big advantage of that. And it's one of the cool things about the Bioconductor build system, is that at least you get reports from all 3. But it doesn't have that immediate reactive like feedback. You have to wait a day and a half before you find out that it didn't build. And then you just have to push another change and wait another day and a half.
But Mike, would you say that in general, if it builds on Linux, then it's fine? Or, I mean, your situation might be a bit special, I know, but for normal packages, usually it's the case that Linux is the one to aim for, or would you divide attention when starting to think about submission to Bioconductor?
I mean, personally, I think the most important one is Windows because 50% of the users are on Windows. Even if it's the least likely one to encounter in your bioinformatics lab. I guess it depends who you're aiming at, but in my experience, the majority of people will have a Windows machine. And so you want it to work on that. I think you're right. If you're just writing R code and there's no compilation or anything complicated in there, probably if you can get it to build on any of those platforms, it will be okay. For a package, I guess you might have to install LaTeX or something along those lines. But most of the time, the pure R code will work on any platform if that's what you're aiming at. But otherwise, I think it's. I mean, I have 3 machines that will let me run on each of the major operating systems for exactly this reason. Like, there's a decent spread of people who want to use any of those platforms, and I don't think it's fair to cut any one of them out, right? Like, I want to support all my users.
Yeah, but just to focus on my actual point, so you would agree that if you fix something on Linux, that's probably most straightforward because most packages can be installed from source very easily and stuff. So would you agree that fix it on Ubuntu, then or on Linux, then most likely it will be fixed on other systems as well, I guess.
And I still think it depends what you're fixing, right? I mean, if it's something that requires compiled code, then that's the compilers and the flags they use and things are different on every platform, and so then it's really difficult to if I fix some C code or something on one of those platforms, there's no guarantee it will work on the others. And I've definitely had that where I think it's fine and then it fails on the Mac because they use C-lang, or it fails on Windows, or I can even fix it on those and then it doesn't work on Linux because there's some assumption that I'm not making. But
I don't know if there are any
Aaron.
more questions for Joselyn, Carmina, and Emmy. Otherwise, I also want to talk about GitHub Actions.
I have one more question, actually. So you mentioned the database. Do you actually distribute, because you said in your initial kind of state before you started making the package was you had the database and you had some functions. Do you distribute the database with the package or as another R package or something, or do you actually connect via the web to a web server or something?
The database is available by a connection with Annotation Hub, so actually the database is already there to take the database. Yeah.
Okay, awesome. So you don't distribute it in the package or anything like that. It's kind of out of your hands, and you connect to the database via Annotation Hub. Great. So yeah, if there's no more questions, I kind of I'm glad you guys talked about how fun testing was, how to make it a game, how important it was, and then I'm going to have to maybe make some horrible confessions about my own experience with testing. But yeah, essentially I wanted to talk about it for a little bit, about unit testing, about whether it probably is important, what people do in certain situations for difficult tests, or and what tools people use and that kind of thing. So I've been kind of inspired. I've used Zoom a bit in the last few weeks, and that has a nice little poll function so people can ask questions. You can all say yes or no or whatever. We don't seem to have that in Blue Jeans. So I'm going to do this might work horribly, but basically I'm going to look at everybody's list and I'm going to ask a question. And then if you could unmute your microphone, and I'll just sort of see how many go unmuted and basically give a bit of feedback. We'll see if this works. If it doesn't, I won't ask any more questions. So we all know you have to put unit tests into your packages because it won't pass the BioC check step, right? You get there's no unit tests, we recommend them. But you can get around that by putting one test in. Not what I recommend, but then the message doesn't pop up and you might be okay. So how many people who have submitted a package are like happy with the amount of tests they put in? They think it's a good test suite versus, I know I'm not going to judge anybody here because you'll see what I've done in one of my packages in a minute. But yeah, so if you could unmute your microphone if you're kind of happy with the amount of tests you put in. I'm just curious. I'd say that was less than half. I get about 7 or 8 maybe. That tally up with what other people think, which is interesting, given that at least 3 people said they've got 98% coverage of their package on here, right? So, and I guess also, what tools do people use? So I think there's kind of, I had a little look before. There's 3 packages that I kind of find normally. There's RUnit. There's hang on, I wrote the name down. What do I use normally? Test that, and then tiny test. So who uses RUnit? Unmute your thing if you use RUnit. Maybe 3, yeah.
If I can just say one thing, like,
yeah,
have used both.
You can unmute multiple times. I'll count you. I'll double count you. It's mostly if everybody uses one package, I guess we'll see. I'm just curious about this. I probably could have gone and looked in the Bioconductor source code or something. This is more fun, right? So not that many people used RUnit. My impression was there. How about test that? A majority, I think. Yeah, probably 2/3, 3/4 maybe. Okay, and then the final one is tiny test. Who, including me? And I only used it yesterday. Not sure if I count really. Okay, so really it's the test that package that everybody. That's by far and away the. Does anyone want to say why they use that package? Just out of curiosity.
Force of habit.
Yeah, so for me, it's a package I learned first when I read the Hadley Wickham book. That's why I started using that one.
So I haven't used like other ones, but I really like the thing that you can see like which line you're looking, and I really like the interface that you can see with the colors, what line you're missing, and I think it's really useful. Like I cannot compare it actually because it's the only one that I have used, but I really like the interface, like the more visual interface.
I was wondering if it was possible to vote for stop if not. We vote for that.
Yeah, so my next thing was going to be what does anybody write their own unit testing? You can just put anything you want in a tests folder, I guess, and it can be run, right? You don't have to use any of these particular packages. I guess I also use test that, and but the majority of things are written in that. I totally agree that. One, it's the first thing you find on Google when you know you've got to write some unit tests, and you get Hadley's book and you get other people that have written articles about Hadley's book and that kind of thing, which is definitely a big selling point for it. I also like the colors and the kind of step through and things. What I don't like is the fact that it depends on 20 packages, at least in the first level of packages. They're listed in the dependencies or suggests is 20 packages, I think it is, which is quite a lot for some of my packages that have no dependencies whatsoever except for so I quite like tiny test, which depends on 2, and the RUnit actually depends only on some base packages. So I've never used that. Tiny test has a very similar interface to the test app package, but I have written one test in it, so I can't tell you whether it is a perfect drop-in replacement or anything. I don't know if anybody else has got any comments on that.
I don't see any big problem with the 20 dependencies, right? Like you usually install them once, you cache them on Travis, or you cache them on GitHub Actions, or the Bioconductor build machines, they get installed. So, as long as these are dependencies that are well maintained, that's the main issue, right? And they don't break as much. I forget if they end up depending on RCCP, but that's the only one that has affected a lot of us, I guess, recently. Right?
Yeah, so I can't remember what the 20 dependencies are, and some of them are only suggests as well. So I guess they don't have to be installed.
For me, it was also a bit like, okay, reading Hadley's book when needed, and then figuring out that teststat has a very minimalistic kind of code base. So it's very very neat, very cleanly written when you write the test. So I like that. Regarding the 20 dependencies, of course, that's a bit of a headache because everything or some things can go wrong. So I agree with that. But currently, I think that it's probably the best integrated package as well for testing.
Well, yeah, I mean, I guess there's a reason why it's become the kind of market leader in a sense, and it definitely does the job, and it's clearly not so resource heavy or so prone to breaking that nobody uses it, right? So I'm definitely not trying to dissuade you from using it. I'm just kind of curious to sort of survey the landscape of what people use and what like is common amongst packages and that kind of thing. I was really surprised. I looked at the RUnit page to download the package earlier, and it lists all the packages that reverse depend upon it. And the vast majority of them come from the Bioconductor project as well, because they now color the links in different colors. So you can easily see whether they're CRAN packages or Bioconductor. And the vast majority come from, which probably is because we enforce having our unit tests in the packages, right? So everybody has to pick one of these testing, or at least put something in there, right? If you want to write, stop. If not, also fine.
Largely legacy, I would say. I mean, our unit existed maybe a decade before teststat, so
I didn't run the same test, right, the same check on the other packages, right? I suspect all of the unit testing packages have a majority that come from Bioconductor in some sense, just because we mandate having the test, and I think that's a good policy to have. But it is also easy. It's easy to game the system in some sense, right? You can have one test and then that's fine. You kind of have some tests. But I don't advocate that we do that. And I really like the point about making it into a game, right? That whoever said, I think that was Emiliano's kind of slide, was you want to get that number higher. And I completely agree with that. So I think having the check coverage, my continuous integration stuff runs and uploads a report to CodeCov so that I can go and look and check that my number's gone up. I get disappointed when it goes down, even though what's happened is I've added lots of code and not a test or something like that. But yes, it's always. I think that's quite a useful thing for motivating you until you realize you can game that system as well by writing really bad tests, but that test all the lines, but don't necessarily do it in a very thorough way. And I don't know what the balance is.
Yeah, just to play devil's advocate a little bit. I mean, we want to, testing mitigates risk, right? So you want to test the code that's actually going to be hit, and you can almost turn this whole thing around and say, for example, if you are lacking coverage over a particular code path, maybe that code path shouldn't exist. Use to simplify your code by identifying the dead code almost.
I would frame it a bit differently. I would say that if you can't write a test for code, then that's a problem. Because sometimes code is written in a peculiar way that you can't write good unit tests for without basically rewriting the whole thing in the tests. And so that's, for me, is like a weird trigger or weird alarm bell to say, this code path, as you labeled it, needs some rethinking.
Yeah, most of my packages have several thousand unit tests. So the one that has the most is Beachmat, and that's got like 40,000 unit tests. And in fact, it takes so long to run that I can't even test it during the package build. It goes into the long tests, so it just gets compiled separately every like 3 days or something. I don't know what the interval is. But yeah, definitely it's, for me, if I have C++ code, that always gets tested, right? That always gets tested with an equivalent R implementation to check that the C++ code is doing the right thing. And where I can, I always check against basically less efficient versions, but more reliable versions of the same algorithm, just completely re-implemented in the tests, and then I have basically effectively 2 different implementations that should give the exact same output.
How do you go about writing 40,000 tests, Aaron?
Oh, it's
like,
yeah. So I write functions that basically loop through scenarios, and then in each scenario it does test that cause. So each scenario maybe has maybe 10 or 20 test that cause, and then I just hit, and then these functions are called by other functions that do, like, for example, they'll call it on an ordinary matrix, they'll call it on a sparse matrix, they'll call it on a HDF5 matrix, and then it just multiplies up, right? I mean, yeah, heaven forbid I don't actually write 40,000 lines of test that code, right? That's just crazy. Yeah, so that's how that happens.
Cool, thanks for that. Yeah, like I think that's a really good point, right? Everybody you start this and you read the examples, and it's essentially writing an R script, and you don't necessarily realize how to build it up into a sort of super comprehensive set like you have. I mean, 40,000 must cover. Are there any duplicates in there? Do you end up doing the same test multiple times because sort of 2 scenarios happen to actually be the same? But it doesn't really matter. But I think it's a really good point to advertise how you go about doing this.
Yeah, so that case is a bit crazy because it's like C++ code and it's all templated, right? So I have to hit, the version for integers, I have to hit the version for doubles, I have to hit the version for, strings and logicals. So the same templated code is probably hit like a gazillion times, right? But it's, I gotta still make sure, it's like, it's so hard to break down at the C++ level because I only get the R interfaces to test to, so I have to hit the same code multiple times in order to do those tests.
Cool, thanks. And yeah, you also raised one point I kind of wanted to advertise, which is long tests functionality, which I think we mentioned in one of these calls 2 or 3 months ago. But Hervé has written a nice little sort of summary on the Bioconductor website about how you can use them, because I think prior to that they weren't really advertised. And essentially, so if you Google Bioconductor long tests, it's the first thing that comes back. And that's a separate folder that you can put in tests that will run for longer than the 40 minutes that you're allowed in the normal build system kind of thing. So if you have something that requires, I think the limit on these is 6 hours. So if you have tests which you want to run with their slightly lower frequency, I think, but it's still several times a week that it will get run, you can put them in this folder and basically use the same infrastructure. It just, you have to put in one extra file in the top level of your package, and then this, you put these longer tests in there, and then, yeah, you get up to 6 hours to run them, but on all platforms, I think it is in exactly the same way. The only thing that you need to be aware of is that if they fail, it doesn't break your build or anything like that. It doesn't stop things propagating. So you have to go and check the results yourself kind of manually. And I don't necessarily think we make that super easy. I'm not sure it appears on you have to go to like a special page of the long test packages. But the instructions are out there, and for you guys that were having running into time limit issues on your package, maybe this is where you can sort of save some of the time. It depends exactly whether it's just the testing that are using this up or that kind of thing. But I kind of wanted to advertise that Hervé has put the instructions out there. And I think Aaron and I are basically the only 2 people that are using it at the moment. But it's a cool resource to kind of make a slightly more comprehensive set of tests if time limit is really the reason why you're not doing that. Does that sound okay to you, Aaron? Does that make sense, your experience with them?
Yeah, I don't know how many platforms it was on. Last time I checked, it wasn't on Windows or Mac. I thought it was just on Unix. Yeah. Yes.
And then I guess I wanted to get back to one thing which had been frustrating me. So I maintain the BioMart package, which queries ensembles databases and I have a set of tests in there that check whether it's working and that kind of thing. And BioMart has been super flaky for quite a long time, but for the last month they've been moving to a new hosting place, and it's been really hard to get a good connection. And essentially my tests always fail. At least one of the checks will fail, and that gives me a fail in the tests, and it doesn't build. And I've resorted to just turning off the tests, which is a really bad approach to this problem. But it's the kind of brute force thing that I just wanted to get a green light next to my package. So there is a test that folder, and it doesn't do anything kind of thing. And so I just guess I wanted to see if other people had experience with kind of querying remote resources that might not be there, that are a bit flaky sometimes, and whether there are tests that I should be doing that I don't just turn them off, right? Like, I'm not happy with this approach, but it's all I've got at the moment.
Can you predict whether the resource is there or not? I mean, like, if you check whether it's online, then you can say, okay, the test will run.
Unfortunately, it doesn't seem to be quite as easy as that. Like, you could do that if it really was down. You could put that at the start of the test or something. But a lot of the time, it will fail. It will fail 1 minute and it will work the next. It's the equivalent of refreshing your browser and the page is there and then the page isn't there and then it comes back again. And you can put in error handling, right? And maybe my code is not robust enough. But when your tests are, am I getting back something sensible? Just get back errors, they would kind of fail.
Yeah. So I think there is a package called HTTR test or something like that, which is also written by the RStudio guys. They have certain functions to test for connectivity, and I'm using that in one of my tests because exactly I don't want to. I've tested all the data processing steps, and then the final thing is, okay, let's do it on some live data. But I don't want the test to fail if the live data is down for whatever reason. So I use that to check, but of course it's just a few kilobytes or whatever which is downloaded. So I don't know if you want to try to like put in some of these calls to skip if the connection drops. Might be worth a try.
Sorry, so what was the name of the package again?
I think it's called HTTR test. It's also from RStudio adjacent, so github.com/rlib.
Okay, perfect. Sounds like it might be really helpful.
Mike, if the remote resource is consistent, like data frame, and it doesn't change much, you can use with mock and test that to sort of hijack the call stack and just mock the data frame that you're getting from the remote resource and run the test from there.
Okay, so that's with mock. That's in the test app package.
Yeah.
Okay. Because I saw that was I got an email from, I guess, an automated email from Martin saying, please make your package fix before the build, like before the release date. And it suggested running that, but it meant nothing to me. And I read the manual page and I still didn't really understand what the hell with mock was supposed to be doing. If anybody knows a good resource with like some examples that are trying to access something online and substituting it in or something, that would be really helpful as well to me. But thanks very much for sort of reinforcing that, Marcel, because like knowing that's where I should be looking means I'll spend some time reading the manual.
Yeah, you're essentially replacing the function in the call stack with your own function. So say if you're calling for the resource and it gives you back a data frame, then you replace that whole procedure with just the data frame that you have created for the test.
And if it's a little bit more low level response you need, so like a stream or something like that, now that Marcel mentioned that, there is a late chapter in the test that book, so to say, I think from Richard Cotton it's written, about faking these kind of connections. I don't know if that will help as well. Maybe it's tied in with the package Marcel mentioned.
Oh, that sounds like a great set of resources to go and look at. This was my like desperate, I just want to get the green light, so I'm not holding up the release, basically. And now I want to go and spend some time finding out what the proper way to do this is. So those sound like excellent resources to go and have a look at. Thanks very much, guys. So I don't know if anybody else has got any more comments or questions about testing, experiences with that they want to bring up. If not, then thank you very much to our first set of presenters. That was a really awesome talk. I really enjoyed it. I'm really glad you guys had a good experience with submitting things to Bioconductor and enjoyed it. Thanks again to Leonardo for sort of making first contact between me and you guys. It's also really helpful. I know you guys had some really excellent mentors. Both him and the rest of that team are really good contributors to Bioconductor. So this has been really good fun. I've really enjoyed it. Thanks very much. And thank you everybody for joining in. I'll try this time to remember to keep